Imagine you're talking to someone who forgets everything you said 5 seconds ago. Every single sentence, you have to re explain who you are, what you want, and what you've already discussed. That would be exhausting, right? Well, that's essentially what a basic LLM does. Every time you send a message, it has no memory of your previous conversations. It starts completely fresh. But AI agents, they are different. They can remember, they can recall what you told them yesterday, learn from past mistakes, and build up knowledge over time. And that ability, memory, is what transforms a simple chatbot into something that genuinely feels intelligent. Welcome back to Agentic AI Simplified. I'm glad you're here for episode 6. Last time we explored the tools that agents use to interact with the world. Today we're diving into something equally fundamental: memory. If you're finding this series helpful, hit that like button and subscribe so you don't miss the next one. So let's start with the core problem. When you interact with a standard LLM, each API call is stateless. The model doesn't know what you asked it an hour ago or even 2 messages ago unless you explicitly include that in the prompt. Now, you might say, but what about the context window? Can't I just stuff everything in there? And yes, modern models have massive context windows, some up to 1 million tokens or even more. But here's the thing: context windows have hard limits. They're expensive to fill and they're temporary. Once the conversation ends, that context is gone. This is where memory comes in. Memory gives an AI agent three superpowers. First, continuity. The agent can maintain coherent, ongoing conversations across sessions. Second, learning. It can remember what worked and what didn't and improve over time. And third, personalization. It can tailor its responses based on what it knows about you specifically. Without memory, an agent is basically a goldfish with a PhD. Brilliant in the moment, but no sense of history. Now let's break down the actual types of memory that AI agents use. And I want to give you a clear mental model here because this is where things get really interesting. First up, short-term memory. This is the most basic form. It's essentially the conversation history that gets passed along with each new message. Think of it as the agent's working memory. There are a few flavors here: a conversation buffer that stores everything, a sliding window that keeps only the last n messages, and token summarization, where older messages get compressed into summaries to save space. Next, long-term memory. This is where things get powerful. Long-term memory persists across sessions. It might use a vector database to store and retrieve relevant past interactions. It could maintain a structured knowledge base of facts the agent has learned, or it could keep a user profile, your preferences, your name, your goals, so the agent remembers you. Then we have two more nuanced categories: episodic memory, which stores specific experiences. Like last Tuesday, the user asked me to debug a Python script and the issue was a missing import. And semantic memory, which stores general knowledge and facts the agent has accumulated over time. These four types work together to give an agent a rich, layered understanding of context. Let me show you how memory actually flows through an agent's architecture, because understanding this pipeline is key. It starts when a user sends a message. Before that message ever reaches the language model, the agent's memory system kicks in. It performs a retrieval step, searching through short-term memory for recent conversation context and querying long-term memory, often a vector database, for any relevant past interactions or stored knowledge. All of this retrieved context gets assembled into the prompt. So now the LLM isn't just seeing your current message, it's seeing your current message plus relevant memories. The system prompt, the retrieved context, and your query all get combined together. The LLM processes this enriched prompt and generates a response. But here's the crucial part: the cycle doesn't end there. After the response is generated, the agent writes back to memory. The current interaction gets added to the short-term buffer, and important information gets encoded into long-term storage for future retrieval. This read process write loop is what makes memory-equipped agents fundamentally different from stateless LLM calls. Every interaction makes the agent a little bit smarter. All right, let's get hands-on. I want to show you how straightforward it is to add memory to an AI agent using LangChain, which is one of the most popular frameworks for building agents. We start by importing the memory modules. LangChain gives us several out-of-the-box: conversation buffer memory, conversation summary memory, and vector store retriever memory. Let's begin with the simplest one, conversation buffer memory. We create an instance, attach it to our conversation chain, and that's it. Now, every message the user sends and every response the agent gives gets stored in this buffer and automatically included in subsequent prompts. If I tell the agent, my name is Rahul, and then later ask, what's my name? It can answer correctly because that earlier message is still in the buffer. Now let's swap to conversation summary memory. The setup is similar, but now instead of storing every message verbatim, the memory module uses the LLM to maintain a running summary. And here's the more advanced setup: vector store retriever memory. We embed each interaction into a vector store. When a new message comes in, the memory retrieves the most semantically relevant past interactions. The beauty of LangChain's design is that you can mix and match these, use buffer memory for the current session and vector retrieval for cross-session memory. So why does memory matter and what can go wrong? The advantages are massive. It enables true personalization. It significantly improves task completion over time. It reduces repetitive questions and allows multiple agents to collaborate seamlessly. But it brings real challenges. Privacy and data retention are major concerns. There's memory pollution. What if the agent stores bad information or surfaces the wrong memory? And of course, storage costs add up. The key insight here: intelligent forgetting is just as important as intelligent remembering. To recap, memory transforms a stateless model into an intelligent agent using short-term and long-term storage. Production systems typically combine summary memory with vector retrieval for the best results. Frameworks like LangChain make this easy to implement with just a few lines of code. And while the benefits are huge, you must design for privacy and selective forgetting. Next time, we're diving into multi-agent systems, where agents share memory and work together. Thanks for watching. Like and subscribe, and I'll see you in the next episode.